Hi everyone, welcome to AI Security Fundamental Episode 1. How LLM actually work and why that makes them hackable. So quick question. Why can a chatbot be tricked into leaking its own instructions just by someone typing ignore everything above? Guess what? It's not a bug. It's not a sloppy coding. It's the architecture. It's back into the way every single large language model on the planet, GPT, Claude, Gemini, Llama, was built. By the end of this video, you are going to understand exactly why, and it's the most important concept in AI security. Full stop. Let's get into it. Self attention. This is the root of every evil. Okay, every frontier model you have heard of run on something called the transformer architecture. This is presented in a paper by Vaswani in 2017, that is, attention is all you need. If you remember one paper title from this whole series, make it the one. Before transformers, we had RNNs and LSTMs. These models read text one word at a time, like you reading a sentence with your finger under each word. Slow, sequential, painful to train at a scale. Transformers threw that out. Instead, they introduced self attention. And here's the plain English version. For every single token in your input, the model asks, how much should I care about every other token in this sequence? Yeah, every token. Checking in with every other token all at once. That's it. That's the self attention. Technically, it's query, queue, key, and value sector and value vector. The model compute a dot product between queue and key, scales it down, and that score becomes the attention weight. You don't need to do that math by hand, but you do need to know those three letters Q, K, and V. Now, GPT style model add one twist casual attention. The model isn't allowed to peek at future tokens, it can only look backward. That's why it generates text left to right, one token at a time, predicting what comes next based on only on what came before. Here is the part that actually matters for security. The attention mechanism treats every token the same way. Your system prompt, the user's input, a document pulled in from a search tool. To that model, it's all just token in a window, attending to each other. There is no architectural wall between instructions I trust and text some random person typed. That's the whole answer to my question at the start of video. Prompt injection isn't a clever hack. It's the model doing exactly what self-attention was designed to do. Just with input nobody mean to trust. Keep that idea in your back pocket. We are going to come back to it in almost every video in this series. Let's go to the section 2. Training, pre-training, SFT, RLHF, constitutional AI. So how does a raw transformer turn into something like ChatGPT or Claude? Three, sometimes four stages. Stage 1, pre-training. The model reads an almost unimaginable amount of text, trillions of tokens, internet, books, code, and learn to do one job, predict the next token. That's called casual language model. This is also where it memorizes the stuff, including things it probably shouldn't have, like snippet of private data buried in its internal training set. File that away. It matters a lot when we get to data privacy. Stage 2, supervised fine tuning or SFT. Now the model gets trained on curated examples. Here's an instruction where a good response. How the SFT works? So we give the instruction and we say, hey, there's a good response. This is where it learns to actually follow directions. Instead of just auto completing text. Stage 3, RLHF, reinforcement learning from human feedback. Human rank outputs best to worst. A reward model learns those preferences and the LLM gets optimized to chase that reward. This is the stage that teaches a model to say, I can't help with that, instead of just helping with that. And then there's anthropic twist, constitutional AI. Instead of relying purely on human ranking, the model is given a right constitution, a written constitution, a set of principles, and it critiques its own output against them. It scales better, more consistent. Now, here's the security hook, and it's a good one. All of this alignment work, RLHF, CAI, comes with a cost. It's literally called the alignment tax. Every ounce of safety training makes the model slightly less capable, slightly more cautious, in exchange of being harder to misuse. And every single jailbreak technique out there, it's an attempt to strip away that tax, to get back to the raw, pre trained model underneath. Capability without guardrails. Let's go to our next section. There are three knobs you control at inference time and why a security engineer should care about each one. Temperature 0 to 2. At 0, model always picks the single most likely next token, completely deterministic. Crank it up and things get random and creative. Security angle. The temp 0 output is predictable, great for testing, but also easier for an attacker to probe and reverse engineer your system behavior. Top P, also called nucleus sampling. Instead of a temperature knob, you set a probability threshold, say 90%, and the model only considers tokens inside that probability mass. Max tokens. Simple but critical. It caps how much the model can generate in one go. Skip this, and you have opened the door to model denial of service. Someone crafting a prompt that makes your model generate forever, burning your computer bill in real time. And one more thing, tokenization. Model don't read words, they read tokens. Tokens are chunks, sometimes whole words, sometimes fragment like unpredictable to un plus predict plus. able. GPT, Claude, and Gemini all tokenize differently, which means the same sentence cost a different number of tokens depending on which model you are feeding it. That matters for cost and it matters for context window math. Speaking of which, context window, that's your total token budget. Input plus output in a single call. Old models, 4K tokens, Claude Gemini today, 200K and climbing. Bigger windows, longer conversation, but also a bigger playground for an attacker to buy malicious instructions where you won't notice them. Let's speed run the major player security lanes only. The Chat GPT or GPT-4, the big one, plugin ecosystem, code execution, browsing. More plugins means more attack surface. Every plugin is a potential tool poisoning vector. The Claude, constitutional AI, long context windows, strong refusal behavior, and Anthropic actually documents its system prompts publicly. Different thread models, different transparency postures. Gemini, natively multimodal, deeply wired into Gmail, Docs, Android, which means a Gemini compromise doesn't stay contained. It can cascade across your entire digital life. Olama, running open model quickly. No data leaves your machine, but also no vendor safety net. You own all of the security now, every bit of it. GitHub Copilot, trained on public code, which means it learned the good pattern and the bad ones. SQL injection, hard coded secret. Copilot will happily suggest them if you are not paying attention. That's the seed of byte coding, a whole topic on its own. Let's go to section 5, the rake, fine tuning, and quantization. Last three concepts, and they all trade capabilities for risk in different ways. RAG, retrieval augmented generation. Instead of relying only on what the model memorized, you pull in fresh document at every time and stuff them into the prompt. Reduces hallucination, keep answers current. But now your retrieval pipeline is an attack surface. Indirect prompt injection can hide inside a retrieval documents, and if you don't enforce access control at retrieval layer, users can see data they were never supposed to touch. Fine tuning, taking a pre-trained model and specializing it. Full fine tuning, a lightweight method called like LoRa, security risk trained on poison data, and you can embed a backdoor that's almost impossible to detect later. Quantization, shrinking the model's precision. IP16 down to int 8 or int 4, so it can run on smaller hardware. Great for local deployment, but quantized models don't always behave identically to their full precision parent, including a safe including on safety behavior. Okay, let's lock this in. Five things, and if you remember nothing else from this video. First, self attention. Self attention has no trust boundaries. That's the root cause of prompt injection. Second, training is pre training, then SFT, then RLHF or constitutional AI, and alignment always comes with a tax. Third, temperature, top P, and max tokens aren't just tuning knobs. Max token especially is your first line of defense against model DOS. 4. Every provider GPT, Claude, Gemini, Olama, Copilot has a genuinely different security postures. Know them. 5th, reg, file tuning, and quantization all by you capabilities. And all three quietly expand your attack surface. That's the architecture piece logged in. If this was useful, smash the subscribe button and I will see you in the next one. Thank you.